Welcome to video lectures for CS8591 computer networks for Unit 2 Data Link Layer and Media Access. This is video lecture for Unit 2 and the first problem is a pure Aloha network transmits 200 bits per frame on a shared channel of 200 kbps. What is the requirement to make this frame collision free? The average frame transmission time TFR is 200 bits divided by 200 kbps or 1 millisecond. The average frame transmission time TFR is 1 millisecond and the vulnerable time for pure Aloha is 2 TFR into 1 milliseconds. That is the average frame time into 2 TFR, that is equal to 2 milliseconds. So the conclusion is what it means: no station should send later than 1 millisecond before this station starts transmission, and no station should start sending during the period that is between 1 millisecond, that is the station is sending. Next, a pure Aloha network transmits 200 bits frame on a shared channel 200 kbps. What is the throughput if the system, all the station together, produces A 1000 frames per second, B 500 frames per second, and what is the throughput for 250 frames per second? Let us go to the solution. The frame transmission time is 200 by 200 kbps or it is 1 millisecond. We will take the case A. A is what is the throughput when 1000 frames per second, it produces 1000 frames per second. So if the system creates 1000 frames per second or 1 frame per millisecond, then G is equal to 1. So in pure Aloha, S is equal to, throughput is equal to G into e power minus 2G, that is 0.135, that is 13.5%. This means the throughput is 1000 into 0.135 is equal to 135 frames. Only 135 frames out of 1000 frames will probably survive. Let us go to the second case. B. B is what is the throughput if the system produces 500 frames per second. If the system creates 500 frames per second or 1 by half the frame per millisecond, then G is equal to 1 by 2. So in this case, that is for pure Aloha, the throughput is equal to, S is equal to G into 2 power minus 2G, that is 0.184, 18.4%. This means that throughput is 500 into 0.184 is equal to 92, and that only 92 frames out of 500 frames will be probably survive. This is a maximum throughput case, that is percentage wise. Let us go for the third case, that is what is the throughput if the system produces 250 frames per second. If the system creates 250 frames per second or 1 by 4 frames per millisecond, then G is equal to 1 by 4. So for pure Aloha, throughput S is equal to, we know that G into e power minus 2G, that is 0.152, that is 15.2%. This means that throughput is 250 into 0.12 is equal to 38. Only 38 frames out of 250 will probably survive. So problem number 3. Now we are going for slotted Aloha. A slotted Aloha network transmits 200 bits frames per using shared channel with 200 kbps bandwidth. Find the throughput if the system produces 1000 frames per second, 500 frames per second and 250 frames per second. Let us go to the solution. This situation is similar to the previous exercise except the network is a slotted Aloha instead of pure Aloha. So the frame transmission time is 200 by 200 kpbs, or it is 1 millisecond. So first one, case A, in this case G is equal to 1. So S is equal to G into e power minus G in slotted aloha. So it is 0.368, that is 36.8%. This means that throughput is 1000 into 0.0368 is equal to 368 frames. Only 368 frames out of 1000 frames will survive. So this is the maximum throughput case in percentage wise. Let us go for the second one, B, option B, that is case B, 500 frames per second. Here G equal to 1 by 2 and S is equal to, throughput is equal to G into e power minus G, that is 0.303. 30.3%. This means that the throughput is 500 into 0.0303, that is 151. Only 151 frames out of 500 will probably survive, right? The case 3, that is C. Now G is 1 by 4. So in this case S is equal to G into e power minus G is 0.195, that is 19.5%. This means that throughput is 250 into 0.195 is equal to 49. Only 49 frames out of 250 will probably survive. Next we will go to the next problem, question number 4, that is a network using CSMA bar CD, carrier sends multiple access bar, collision detection, has a bandwidth of 10 Mbps. If the maximum propagation time, including the delays in the devices and ignoring the time needed to send a jamming signal, is 25.6 microsecond. What is the minimum size of the frame? So solution is, the minimum frame transmission time TFR is equal to 2 into TP, that is 25.6 into 2, that is 51.2 microseconds. This means a station need to transmit for a period of 15.2 microseconds to detect the collision. The minimum size of the frame is 10 Mbps into 51.2 microsecond, that is 512 bits or 64 bytes. So this is actually the minimum size of the frame for standard Ethernet. The last problem, question number 5. What is the number of sequences if we have 90 stations in our network? So the number of sequence needs to be 2 power m. We need to choose m is equal to 7 and n is equal to, capital N is equal to 2 power 7 is R128. So we can use 90 of the sequences as the chips. Thank you.